Welcome to Workplace HSE Explained, your go-to channel for clear, practical, and engaging safety insights. Here, real workplace hazards, OSHA-inspired topics, near misses, and prevention strategies are broken down into simple, easy-to-understand lessons. Whether you work in construction, warehousing, manufacturing, oil and gas, logistics, or even an office environment, every video helps you spot risks faster, work smarter, and stay safer. If you care about hazard awareness, safety culture, incident prevention, and protecting people at work, you're in the right place. This is Workplace HSE Explained, where safety becomes simple. A quiet construction site, a clear sky, and two massive crawler cranes standing like steel giants. Nothing about that morning hinted at disaster. Workers moved with routine confidence, supervisors checked their lists, and the air felt almost peaceful. But hidden beneath that calm was a tiny misunderstanding, a single misheard instruction that would soon unleash chaos. This is the story of how a simple miscommunication triggered a multi-crane collapse, a disaster that could have been prevented with one clear sentence. Before we dive in, imagine this. Two cranes lifting the same load, each depending on the other, like two people carrying a long table. If one moves too fast, too slow, or in the wrong direction, the entire system becomes unstable. That's exactly what happened here. The lift plan required perfect synchronization, but the operators received different instructions. One operator heard, "boom up 2 degrees," while the other heard, "track forward 2 meters. Neither instruction was wrong on its own, but together they created a deadly conflict. As the lift began, the load shifted unexpectedly. The first crane compensated by booming up, while the second tried to move forward, twisting the load between them. Ground workers noticed the tension building in the slings, but by the time they shouted, the cranes were already fighting physics. The load swung, the cranes tilted, and the operators, confused and reacting instinctively, made rapid corrections that only worsened the imbalance. Within seconds, the combined center of gravity moved outside the safe zone. One crane tipped first, pulling the second with it like a domino effect. Steel screamed, alarms blared, and the ground shook as both machines collapsed in a tangled heap of metal. And all of it began with one misunderstood instruction. In this video series, we'll break down exactly how miscommunication creates mechanical conflict, why multi-crane lifts demand absolute clarity, and how simple human factors can trigger catastrophic failures. Let's start by understanding the psychology behind miscommunication and why even experienced operators can hear the wrong thing during critical lifts. To understand how miscommunication becomes deadly during multi-crane lifts, we need to explore what happens inside the human mind during high-pressure operations. Crane operators work in environments filled with noise, radio chatter, wind, vibration, and constant movement. Their brains filter hundreds of signals every second, prioritizing what seems most important. But this filtering process can distort messages, especially when instructions sound similar. Words like boom, slew, track, hold, and up can blur together when radios crackle or when accents differ. In our incident, the supervisor issued instructions quickly because the team was behind schedule. He said, "Crane 1, boom up 2 degrees. Crane 2, track forward 2 meters. But both operators were using the same radio channel, and the second operator only heard the first half of the message. He assumed the instruction applied to both cranes. This assumption is a common cognitive shortcut called pattern completion, where the brain fills in missing information based on past experience. He had done synchronized boom adjustments many times before, so his mind defaulted to what felt familiar. Meanwhile, the first operator heard his instruction clearly, but didn't know the second operator had misunderstood. When the lift began, each operator believed they were following the correct plan. This is the dangerous part. Miscommunication doesn't feel wrong in the moment. It feels normal. And when both operators act confidently, ground workers assume everything is under control. As the load shifted, the slings tightened unevenly, creating asymmetrical tension. The cranes began compensating automatically through their hydraulic systems, but hydraulics can only correct so much. The load started rotating slightly, a warning sign that should have triggered an immediate stop. But the operators interpreted the rotation differently. One thought the load was drifting because the other crane was lagging. The other thought the rotation meant he needed to move faster. Both increased their adjustments, amplifying the instability. This is how miscommunication evolves from a small misunderstanding into a mechanical conflict. Machines respond to physics, not intentions. When two cranes receive conflicting commands, the load becomes the battleground. In the next part, we'll break down the exact mechanical chain reaction that caused the collapse and how physics punishes even tiny coordination errors. Now, let's break down the mechanical chain reaction that turned a routine tandem lift into a catastrophic collapse. Multi-crane lifts rely on shared load distribution. Imagine two people lifting a long steel beam. If one person raises their end even slightly, the entire beam tilts. Cranes behave the same way, but with far greater consequences. In this incident, Crane 1 boomed up while Crane 2 tracked forward. These motions pulled the load in two different directions, creating a twisting force called torsion. Torsion is dangerous because it increases stress on slings, shackles, and crane booms. As torsion built up, the load's center of gravity shifted away from the planned lift path. Crane 1 suddenly carried more weight than Crane 2, even though both were rated for equal load sharing. This imbalance pushed Crane 1 closer to its tipping point. The operator felt the crane leaning and instinctively boomed down to stabilize, but this action caused the load to drop slightly on his side. Crane 2 interpreted the drop as a signal to move forward faster, trying to catch the load. These opposing corrections intensified the torsion. The slings stretched unevenly, the load rotated further, and the cranes began fighting each other. Crane 1's boom angle exceeded its safe operating window, reducing its stability. Crane 2's tracks moved onto softer soil, decreasing ground support. The combination was lethal. Crane 1 tipped first. As it fell, the load jerked violently, yanking Crane 2 sideways. Crane 2's operator tried to slew away, but the sudden lateral force overwhelmed the crane's counterweights. It toppled, crashing into nearby equipment. The collapse happened in less than 6 seconds. Ground workers ran for cover as debris scattered. The supervisor froze, realizing the disaster began with his rushed instructions. The physics were unforgiving. Once torsion exceeded the crane's ability to compensate, collapse became inevitable. In the next part, we'll explore how this disaster could have been prevented with simple communication protocols, better planning, and human factor awareness, and we'll close with a powerful outro that reinforces why clarity saves lives. Preventing this disaster didn't require advanced technology or expensive equipment. It required clarity, patience, and disciplined communication. Multi-crane lifts are among the most complex operations on any construction site, yet they often fail due to simple human errors. A first prevention step is a unified communication channel. Instead of giving separate instructions to each operator on the same radio frequency, supervisors must use structured, sequential commands. Crane 1, stand by. Crane 2, stand by. Crane 1, boom up 2 degrees, confirm. Each operator must repeat the instruction aloud. This repetition eliminates assumptions and forces clarity. The second prevention step is a designated lift coordinator who communicates only with crane operators. In our incident, the supervisor was multitasking. talking to riggers, signalers, and operators simultaneously. This divided attention increases the risk of miscommunication. A lift coordinator focuses solely on the cranes, ensuring every instruction is heard, understood, and confirmed. The third prevention step is pre-lift simulation. Operators should walk through the entire lift verbally before touching the controls. This mental rehearsal aligns expectations and reveals misunderstandings early. The fourth step is emergency stop authority. Any worker, rigger, signaler, or operator should be empowered to shout "stop" at the first sign of instability. In this incident, ground workers noticed tension building in the slings but hesitated because they assumed the operators knew what they were doing. Empowering everyone to intervene creates a safety net. Finally, human factor awareness must be part of every lift plan. Stress, fatigue, noise, and time pressure distort communication. Recognizing these factors helps teams slow down and prioritize clarity over speed. And now, the outro. A multi-crane disaster doesn't begin with steel, hydraulics, or physics. It begins with a single, misunderstood sentence. When communication fails, machines cannot save us. But when teams speak clearly, confirm instructions, and respect the physics of lifting, disasters become preventable. If you found this breakdown valuable, follow Workplace HSE Explained for more real-world safety stories that protect workers and save lives.